Welcome to the course Business Analytics and Text Mining Modeling using Python. So, in previous few lectures we have been able to complete the built-in capabilities aspects as also. So, now we will move into the another important package, that is NumPy, that is numerical Python package. This package is especially useful for generic numerical data processing, and though in analytics context we are typically required to work with the tabular kind of data. For that we will also in the coming lectures we will discuss, we will learn about the another package, that is Panda. However, this is also very much important because we would be dealing with the larger data sets, and while we are dealing with the largest data set, certain processing, certain data processing, certain data transformation, certain operations that we will have to perform. For those purposes this particular package can be really useful in the analytics context. So, let us start our discussion on this particular package NumPy. So, this is as you can see in the comments, this is typically used for typical numeric data processing, and the big advantage of this particular package over the Python built-in capability is in terms of execution. So, faster the code can be executed much faster, and also the memory utilization is more efficient memory utilization. It happens using the algorithms based on this package, using the functions and code based on this particular package. So, it has certain advantages over Python built-in capabilities, built-in functionalities that we have. So, therefore, suitable for working with larger data sets. So, if any processing that is to be done on a larger data set, so probably functions from this package would be better than writing code using the built-in Python capabilities, functionalities. So, as usual first thing would be to load this package into the Python environment. So, this is import NumPy. We typically use np. So, let us run this, and then one of the important aspects of this package is this n dimensional array object, ND array. So, this particular object is really useful for data processing because it can very efficiently store large data sets and very efficiently can be used to perform operations on those data points. So, let us talk about n dimensional array object. So, as you can see here, again a generic multi-dimensional container for elements of the same type. This is an array. So, just like list object that we talked about in the Python built-in capability session. So, there this array is one dimensional array, especially specifically one dimensional array is going to be quite similar to list objects that we have discussed before. So, array is a multi-dimensional container. So, we will see through examples how this can be worked with. So, suitable for large data set and it acts as a container. Now, there are various array creation functions that can be used to create these objects, array objects. So, let us start with the first one, the most common one is the array function. So, conversion of Python objects mainly sequences and even their list object into an array can be done using array function. So, here you can see I have given one example. So, here np dot array, this is the function that we are using, and within the parenthesis the only argument that we have here is the data that we are passing, which is actually a list object. So, in this list we have these 5 elements and this is being passed as the argument here in the np dot array function, and this function will convert it into an array object. So, if I run this, I will get an array object. So, this is a one dimensional array with 5 elements. So, if I try to print this array object here, you can see in the output number 3 array 1, 2.1 point and 2.1, 3 point, 4.3, 5 point. So, you can see most of the elements in this are being stored using the floating point data type. So, you can see one dimensional array with 5 elements. So, very similar to the list that we have learned in previous sessions. Now, let us take another example. So, in this case we are taking we can convert nested sequences of same length into a multi-dimensional array. So, the sequence, if same length sequence we can take, and then we can create this multi-dimensional array. So, here again you can see we are using the same function np dot array, and here this is a list of lists. So, comprising of this list is comprising of two lists, and you can see 4 elements in each of these lists, 1 2 3 4 elements in the first list, then 1.1 2.2 3.3 and 4.4 4 elements in the second list. So, this particular list can actually be used to create an 2 dimensional array. So, let us run this, and you can see if we run this access this array again, then we can see that a 2 dimensional array with the 4 elements in each dimension has been created, and you can see array, and you can see within the parenthesis 1.2.3.4 point. This is these are the elements of the first dimension, then 1.1 2.2 3.3 and 4.4 these are the elements of the second dimension. So, in this fashion we can create a multi-dimensional in this case 2 dimensional array. Now, let us take another example. So, here you can see we are again using the same function np dot array, and the argument, the first argument is on data, input data that we want to convert into an array. So, 4 elements, list with 4 elements. However, in the second argument we are also specifying in this example the data type. So, here we are specifying the int integer data type here. So, the array, even though the input data and all the elements of this particular data list data they are floating point numbers, but since we are trying to create an array comprising of integer elements by specifying this d type keyword argument here. So, appropriately then this array is going to be created. So, let us run this. Now, because the list elements were floating point number and we are trying to convert into an integer array. So, the decimal part is going to be truncated. So, if we look at the output for array 3 here. So, you can see output number 7, array 1 2 3 4, and the original data was 1.1 2.2 3.3 and 4.4. So, because of this conversion, because of the this conversion into an integer array from a floating kind of list, this decimal part has been truncated here. So, this is how we can use array function to create to rather convert Python built-in objects into an array numpy object, numpy array object. So, this is one way. There are other array creation functions. So, which can also be used to create array objects. So, we will see them through few examples. Now, before we talk about those functions, let us discuss some of the properties of array objects. So, first talk about number of dimensions. So, given an array, how do we find out the number of dimensions that are there. So, for this we have this ndim metadata object or ndim attribute that can be used to find out the number of dimensions of an array. So, here array object we have already created. So, array dot ndim, if I run this, I will get the number of dimensions. So, in this case the array object that we have earlier created, it just had one dimension, as you can see in the output number 3, just one dimension with 4 elements. Now, the second array object that we had created, array 2 dot ndim, here we have, if I run this line, then number of dimensions comes out to be 2 in the output 9. So, you can see, and as you can see in the output 5 there were 2 dimensions. So, number of dimension we can find out using this metadata object. Similarly, if we want to find out the full detail, in the sense the number of dimension and the size of those dimensions, then we can use another metadata object, another attribute, that is shape. So, array dot shape will give us the actual shape of an array object, or rather number of dimensions and the sizes of those dimension. So, let us run array dot shape. Now, as we know that this is one dimensional array. So, therefore, if you look at the output 10, it is just one value is there in this output, and that is depicting the number of elements that are there in the one dimensional array. Now, if I take another example, array 2 dot shape, then in this case you would see a tuple is returned where two elements are there, and the first element 2 is indicating the number of dimensions, and the second element 4 that is indicating the number of elements in each of those dimensions. So, 2 comma 4. So, that is telling us about the shape of this particular array 2. So, in this fashion we can learn about some of the attributes, some of the properties of array objects, whether it is about the number of dimensions or the sizes of those dimensions. Another important metadata object about or property of an array object is the data type that is being stored in a particular array object. So, how do we find out that? So, we can use the D type metadata object in this case. So, what it does, this D type metadata object will indicate the type name, whether it is float, integer or string or something else, and the number of bits per element that have been used to store those elements. So, array dot, if we execute this array dot D type, then we will come to know about the data type that has been used to store elements of this array object ARR. So, if I run this, you can see in the output number 12 we get D type float 64. So, float is indicating the type name, the data type, and the 64 is indicating the number of bits that have been used to store each element of this particular data type for this array object. Now, similarly we can also run array 2 dot D type. So, in this case you can see D type float 64. So, array 2 also happens to be same kind of data type. Now, similarly array 3 also we can check here. So, here you can see again array 3 was data type for the array 3 object was integer 32. So, type was integer and 32 bits for element were used to store those elements of array object. Now, let us move on to the next aspect. So, now let us talk about few more array creation functions that can be used to create array objects. So, let us talk about the zeros function. So, we can use this function again in a sense to initialize an array object. So, if I execute this code np dot zeros, and in the only argument that I am passing in this example is the 5. So, that is actually to indicate the number of elements in that one dimensional array that we want to create, and the array would be created and all the elements of this newly created array will be initialized with the value 0. So, if I run this zeros function here np dot zeros 5. So, you can see output number 15 and we have got this one dimensional array with 5 elements, and each of those elements are 0 0.0. So, from this you can also understand that the default value for these array creation function, the default data type for these array creation function is the floating point. So, that is why in the output it is coming, it is being displayed as 0 point something. Now, if you are interested in finding out more details about these functions, different arguments and how they are to be used, that you can always do by going through the help section. So, if I click help, now you can see Python reference, IPython reference, NumPy reference. So, for earlier two sessions that we have covered, the one on Python basics, the other one on the Python built-in capabilities, we were mainly using the Python reference here. Now, we have started our discussion on NumPy package. So, we would be using the NumPy reference now for any details about any functions, methods that we would like to find out. So, if I click the NumPy reference here, we will get a NumPy documentation here. And the quick search function, we can always go and whatever function that we are interested in, we can always go type that in the quick search. So if we want to find out more details about the zeros function, we can just type zeros, and you can see numpy.zeros. This is the function, this is the Python function that we are looking for. So here you can see the details. The first argument is the shape, so we are supposed to specify the shape of the function. Then d type, which you can see it is keyword argument, and the default value is float. Then we have another argument order. Now let's go through the parameters, these arguments. So shape, int or tuple of ints. So example could be we can specify this 2 comma 3 in this fashion. We can specify the shape like 2-dimensional array with 3 elements in each dimension, or if it is 1-dimensional array, we can specify just the number of elements. So example that we just have gone through, we had specified 5. So you can see the same example is here you can see np.zeros 5 array, and this is the same output we also got there. So anytime when you are looking to find out more details about a certain function, you can always go to the help section, find the relevant reference link, and just search it out using the quick search box. So let's go back. Now in this example, we had just passed on the just one number that was to indicate the number of elements for 1-dimensional array, and everything was initialized with zeros. Now we can use the same function np.zeros. Now this time we are passing on a tuple with 2 elements 3 comma 3. So essentially we are trying to create a 3-dimensional array with each dimension having 3 elements. So if I run this, so you can see in the output number 16 array, you can see 3 dimensions, 3 rows of data are there. So we can also think about these arrays as the rows and columns, and later on we will talk about how to access these elements of the array. And just like the list object which were geo indexed, the arrays are also 0 indexed. So we will talk about those aspects also. So here you can look at it like rows and columns. So each row can be thought of as representing 1 dimension. So there are 3 rows in this output number 16. So 3 dimension. So the same thing we indicated in the first argument, and in the second argument also the value is 3. That is to indicate the number of elements in each of those dimensions. So if you look at the number of columns, so that would be equal to the number of elements that we like to have in each of those dimensions. So the number of rows are like number of dimensions, and number of columns are like number of elements in each of those dimensions. So in this fashion we can understand the output or any array object. Now let's take another example for np.zeros. Now in this case the first argument, as you can recall the reference also here, you can see shape and d type. So now we are going to use the second argument also d type. So this in the first argument we are passing a tuple with 3 elements 2 comma 3 comma 3. So this is to indicate that we are looking to create a 2 cross 3 cross 3 array, and the data type of the elements that are to be stored is integer, that is the second argument. So if I run this here np.zeros, you can see the output. Now here you can see that the first element first argument was 2, and so in a sense we can consider that it is comprising of, so the array this multi-dimensional array with 2 cross 3 cross 3 cross 2 is consisting of 2 arrays of dimension 3 cross 3 cross 2. Then again the next level can be considered again as 3 arrays of 3 cross 2 sub arrays. So in that fashion we can think about these outputs. So let's go back to the previous example. So you can see
here in this case 2 comma 3 comma 3 d type int. So, you can see all the elements are 0 filled, and first array 3 cross 3, first sub array rather 3 cross 3, then second sub array 3 cross 3. So, in this fashion we can understand. And the next example that we just talked about, output number 18 also in the same fashion as I discussed. First first element will have another sub array with 3 cross 3 cross 2, and second element will be the second one 3 cross 3 cross 2, and the data type is integer. So, we really need to see how these arrays are to be understood. All the elements are having the same data type, and when we are using the zeros functions, all of them are being filled with zeros. And how the dimension aspect is to be understood, rows and columns aspect that I just talked about. So, how that is to be understood has to be very clear. Now, let us take another example. Now, in this we will be using another array creation function, that is ones. So, it is very similar to the function zeros. So, in the function zeros, the values were filled with zeros. In this case, the values are going to be filled with ones. So, if I take this example np dot ones, and the only argument that we have, we are passing the value as 8. So, we will be creating a one dimensional array with 8 elements. So, if I run this, you can see in the output number 19, we got an array with 9 elements, and each element is having the value 1 point. So, because the default is float, as we saw in the reference also. So, let us take another example for this function. So, now this time we are passing on np dot ones, we are passing a tuple, which is indicating the kind of array that we want to create, which is 2 cross 4 cross 4. So, that means first first sub array would be a 4 cross 4 array, and the second sub array would be again a 4 cross 4 array. So, in this fashion we can understand the sub array elements, and then go on further. So, if I run this, as you can see the output, you can see all the values are filled with ones, and we can clearly understand the dimensions which were passed on as arguments, 2 cross 4 cross 4. Similarly, in this function also we can specify the second argument, that is d type, to specify the data type to be used. So, you can see in the output, if I run this here, you can see in the output all the decimal part is gone, decimal part is truncated, because we changed the data type for each element. Now, let us talk about the another array creation function, that is a range function. So, we are already familiar with the range function that we have used in Python built-in capabilities for different sequences. Here also a similar kind of function is available to us, which is a range function. So, let us understand this. So, here in this example I am calling this function np dot a range, and the value that I am passing is 6. So, here if I run this, in the output you can see array 0 1 2 3 4 5 6 element. So, this is creating this a range function is creating the elements in a range fashion. So, the only argument that we have passed on is the stop point, and by default it has taken the start point as 0. So, from 0 to up to the number of elements that are to be there, 0 to 5 have been created. Just like it's the functionality is very similar to the range function that we have understood earlier. So, if we go back to the Python reference and we type range here, and if we search, you can see here again start stop. If you look at the arguments here, start stop. So, you can see start is optional, stop is the only mandatory argument here. The other arguments are optional, and d type is the keyword. So, again it is optional. So, in this fashion you can see a range can be really useful sometimes to quickly create arrays. Now another example for a range function. Now this time I am specifying both the start and stop point. So you can see 5 comma 20. So the values will start from 5, and as we have learned in the range function, the stop point value will not be included. So you can see from in the output, if I run this, output number 23, 5 to 19, this kind of sequence has been created here. This kind of series, numerical series from 5 to 19 has been created, and this array object has been created. Now let us talk about another aspect of NumPy, that is the supported data types. So what kind of data types are supported in this package? So floating point, complex, integer, boolean, string, general Python object. So for all kinds of data types we have support in this package. So we will learn this through few examples. So given these different data types, how we can convert one object from one data type into another data type. So we are talking about array here. So how we can cast an array from one data type into another. So for this we will be using as type method. So let us take the example of array 3 that we had earlier created. So let us run this. This is the array 3, one dimensional array with 4 elements, and let us look at the data type for this array. So array 3 dot d type, and you can see the data type is int32. Now if we want to convert it into some other data type, so array 4, we are trying to create a new array object, and in this we are using array 3 dot as type. We are converting array 3, casting array 3 using another data type, that is np dot int64. So instead of using a 32-bit integer, we would like to use a 64-bit integer here. So smaller int to bigger int, this is the kind of casting that we are doing here. So if I run this and if I check array 4 dot d type, you can see int64. However, if I look at the values, so in the output also you can see in this that d type has been changed. Similarly, integer to float. So here again we can use as type, and in the argument we can pass on np dot float 32 if we want to use a 32-bit floating data type. So let us create array 4 using array 3 and casting array 3, and if I look at array 4, and you can see that in the output, earlier all the values were integer 1 2 3 4. Now we can see a decimal point also there, because the casting has happened and it has been converted into a floating point. Let us move on. Float to int. So whenever this kind of casting is done, the decimal part is going to be truncated. So there is going to be loss of data in this case. So we have to be aware of this. So let us take this example. We will cast array 4 into a 32-bit integer. So let us run this array 5 that we have just created, and you can see the decimal part is gone. Sometimes a string values might be containing the numbers, so in the single quotes or double quotes. So let us take this example array 6. So let us first create this array using array function np dot array. So this is the string object that we have, and values. Let us output the values. So you can see 3 elements, this array with 3 elements of string type, and you can see the data type is also mentioned slightly differently from the way we have seen till now, integer, floats kind of type. This is a string type, and now we can use this example to convert this string type array into a float type. So we can again use the as type, and here you can see in the next line 54 rather 35. If I run this, you can see as type float. So I have not mentioned np dot float here. So you can always because the what NumPy does is it is running aliases. So in the sense Python types are going to be converted into the equivalent NumPy data types. So, therefore, there is going to be no problem here, and you can see in the output 35 array we have got 3 element here without any issues. Now, let us take few more examples. Now, this time in this array I have the first element is a really long floating point number, many decimal points running up to many decimal points. So, let us run this and you can see this is. So, now here you can see because this is also using the string data type. So, you can see the data type is changing. The earlier example that where we had the smaller floating point number within single quotes 1.1 and all that minus 5.5 and 9, we had U4 because 4 bytes were used. Here in this case you can see 20 bytes have been used, that is because of the number of characters that have been packed into the first element in this array. So, depending on the the way the string values are being initialized, so that much storage fixed storage is going to be allocated for this. So, you can see that is being reflected in the data type object as well. Now, if we convert this string array object that we have just created to float one. So, if I run this next one, so you can see array 7.h type nb.float, and in the output you can see that in the array 7 output we had a really long floating point number within double quotes. So, that was accurately displayed there in output 36. However, when we casted it into float, you can see that the value has been truncated, right. So, that is a kind of data loss. So, there is no warning for this. So, one has to be really cautious about these kind of castings, because there it might result in some kind of data loss. Now, if I check the data type for this float array that we have just created, if I run this, you can see float 64. So, because we are just using 60 bits for each element, that means about 8 bytes, and the actual array with the string values it used 20 bytes. So, therefore, the change is clearly noticeable here. Similarly, let us take few more examples. Here you can see np.array, and in this example you can see another longest value floating point value here. If I run this, and again if I want to cast this into the string type, so you can see how the casting to string type is happening. So, you can see here. So, this is in a sense is happening in this binary mode. B is appended everywhere. So, you can see this. Now, there is another way to use data types. So, we might have created objects, array objects earlier also, and we would like to keep the same data type which we had used for the earlier array objects that we might have created. So, that can also be done. So, let us take the example of array 3. So, array 3 dot d type, the data type in this case is int 32, and array 4 d type, the data type in this array object is float 32. So, again I can use as type function, and I can cast array 3 using the array 4's data type. So, in the argument that I have, I can pass on array 4 dot data type. So, this is another way to convert. So, you can see that in the output number 43 the data type is float 32. So, we would like to stop here, and then we would continue our discussion on NumPy in the next lecture, where we will talk about the sort and type codes as well that can be used to perform this kind of casting or conversion. Thank you.